going live, and I'm live, yay. So they installed those machines in the hallway, those air conditioning machines, and we got an email about it like half an hour later, basically saying that, okay, well, when we turned on the air conditioning unit, that air conditioning unit that hasn't been on since like last year or the year before, there was a piece that broke in the chiller. And so they ordered a piece from the manufacturer, and they received that piece in order to fix the chiller in C-Wing. And it turns out that the piece that they received was defective. So they were like, that's a shame. Let's order another piece. And then they find out shortly after that the entire batch of those replacement pieces from that company or manufacturer are defective. So they were like, turns out we can't fix the chiller in C-Wing. So let's just bring in these giant units, pumping out, air into the hallways. And hey, teachers, close your windows and keep your doors open. Oh, here we go. Hold on.
Michaela Croswell, please report to the nurse. Michaela Croswell, please report to the nurse.
But it's like, you got to think, like, I don't know the last time they put on those air conditioning units. I mean, they must have turned them on at the end of last summer. It was like, I don't even know, 6 months of inactivity. Oh, what a fun world we live in. Okay, here we go. Today, Thursday, I want to do a little bit of an experiment, but that experiment is going to involve you and your Chromebooks. So while I'm kind of explaining what's going on, I'm going to give you an opportunity to break out those Chromebooks and get logged on as quickly as possible. And then I'm going to be throwing this experiment at you. Basically, being that it is a full day, we have until 8:43 until this class period ends. So we have roughly 83 minutes or so. So what I would like to do is I would like to get started with what I'm doing as quickly as possible. I am going to be throwing a practice quizzes at you in a few minutes. And this practice quizzes has 40 questions. Now, these 40 questions range from almost anything that we've covered in the past however many months since September in AP Stat. Now, it's again practice, but being that it is 40 questions, I am going to put a timer up on the board for 60 minutes. Now, obviously, not all of you are going to use the full 60 minutes. Some of you are going to go under, some of you are going to go over. But I do want you to try and time yourself out on each question to less than 2 minutes per question. I think that would be ideal. We want to make sure that we kind of get this idea of like, okay, how long is a minute and a half? How long is 2 minutes? Am I spending too much time on this question? Do I have enough time at the end? Because if I put 60 minutes on the clock, when you do the AP test on Tuesday, you would then have an additional 30 minutes because you have 90 minutes on the multiple choice, but then you would have an additional 30 minutes to go back and recheck those questions. You have 90 minutes on Tuesday for the multiple choice. So it can feel like an eternity, or it could feel like a blink. And I kind of want to get you used to this kind of feeling of going through these questions and with that timing. And it's what I've tried to do most of the school year. Now, when those 60 minutes are up, obviously you can't go back and change any of the answers. You're going to know immediately whether you got it right or you got it wrong. At the end, you'll be able to review those questions on your own. So with whatever time is left over on the clock for 60 minutes, when you're done with the 40 questions, please review the questions that you got right, the questions that you got wrong especially. And then with the time that we have left in the class period, I would like to hit up those questions that we struggled on the most. So that would be ideal. For those of you in the chat, if you would be so kind as to leave a comment, that would be absolutely wonderful for my attendance. And I'm going to throw this code over to you. Come on, you. Right there. There we go. That's the code that I have set up. Now, last class, I had thought that I was going to go over a few linear regression problems with you. I'm still going to do that, but not in a class capacity. I'm still going to give you the ideal solutions to those linear regression problems that I gave you. But I won't do that during this class period. I think I'll just do that as kind of a, hey, here are the answers to those questions kind of thing. Let me double check the chat here again. It's not loading on my thing. I got to type in the code just in case they can't see it. That'd be wonderful. Now, obviously, once we get this thing moving, then I'll put the timer on the board. So I won't have the leaderboard up here. Oh, yeah, you do. Yeah, absolutely. You do your thing. I know. Yeah, in the corner right here, there is one. Let's see. There we go. There are the people in those chats. Come on. Just need to switch that over.
I have to charge mine too.
I have an that could work. Hold on one second. No, that can't work. Sorry. How far does your cord reach? Because I might be able to plug you in up here. Are you gonna untangle that? Somebody, again, for the people in the chat, please make sure that you're joining this thing. That would be absolutely wonderful. There's too many threes. There we go. 62, 33, 42. Boom. There we go. So what I figured is we'll just put the cord underneath this thing. If need be, I could put it over there. Like here, see if it. Oh, where does it plug in? In the computer? What side? On that side? Okay, we'll go over this side then. Yeah. Okay. Let's see how far this goes. Come on. Won't this thing work? Yeah. Child-proof locks. There we go. That was mine, by the way.
Thank you.
If this is yours, there we go. Hopefully that'll do something. Okay. And we got 14. How am I getting here? 8, 12, 3, 15. Okay, cool. All right, make sure you are getting logged on. If you have not logged on yet, that code will be, well, actually, I'll just write it on the board because I'm going to change the screen over. So please make sure that you are getting logged on as quickly as possible. Cool. Okay. Like I said, these questions could potentially be on anything. Read carefully, and please try to time yourself out to approximately less than 2 minutes per question. I say approximately because obviously if you go over, you could save that time on other questions. If you only spend 15 seconds on one question, you can bank that time for a later question. So please keep that in mind. Let's see. Let me get the timer up here. Hold on. Timer. 60. There we go. And I'm going to get this thing started. Start. And start. I'm going to turn off that music. No worries. For me, at least. There we go. And there we go. Six, 2, 3, 3, 4. Hi, you called me a little bit ago. Okay. Oh, I'm sorry. Okay. Gotcha. You too. Bye-bye. Just remember, if you get to a question where the picture seems too small, I believe Quizzes has that option where you can click the picture and we'll make it bigger. I know several people have finished so far. The time is still going to keep going because I still have about half the class still trying to finish. But if you did get done early, double check those questions that you got wrong. I'm going to be going over some of the more difficult ones according to quizzes once we're relatively all complete.
I go to the bathroom?
Oh,
For you guys that are still working, I'm going to give you another couple of minutes. I'm just keeping track of where everybody is over here. But just another couple of minutes, and then I want to see where what questions we're gonna go over. Okay. I'm gonna click to enter the thing in just a moment. If you still have your quizzes open, please try to keep that open because I am going to be referring to certain problem numbers as we kind of go along here. But I'm going to click to end the thing, and then I will show you exactly what you did kind of on average. Cancel that, reset that. There we go. End. There we go. Good, and good. Flip the screen over. There we go. So, as a class, according to this thing, you guys averaged about 58%. And you're thinking like, okay, well, 58% out of 40 questions. Again, let's just assume this is the actual AP test. 58% means you would have gotten 23 correct, potentially, give or take. 23 correct. Now, I have to tell you, all things considered, check this out. This is one of those AP grade calculators. Again, this is a different one than the one that I've shown you before. What I did was I automatically set all the free responses to a 1. I set all the free responses to a 1. Okay? Clearly, you're going to do better than a 1 on those free response questions. But if I set a 1 as for all of those free response questions, and then I put, what you guys did, a 23, look at that composite score right there. Look at that composite score. 41 out of 100 is the composite score, according to this calculator. 41 out of 100. That's not great, but again, this is a hard damn test. You get 41 out of 100, that is a passing score on the AP test, just with an average of 23 correct. That's what you guys averaged today. Now, obviously, these questions were a bit faster. You're on the computer. Some of them were just, meant to kind of just get your mind focused on what it is that you're going to be seeing next week. But if you absolutely nail that multiple choice, let's say you don't even get 23. I mean, if you just get like 25 or 30, you're pretty much guaranteed to pass this thing. But let's say you do a little bit worse, and it's like, okay, well, I got 19. Oh no, I got 19 correct. I got less than 50%. Oh no, my predicted score. All right, well, that's why one of these free response questions, I guarantee you're not going to get a 1 on the free response questions. You read the free response question, you take your time with it, you give them the information that they want, you go through the procedures that we've been pretty much practicing all year long, you should be fine. Let's say you get like a 2, a 2, a 2, let's just say then you bomb the rest, and then maybe you got like a 20. Oh, there it is. You got 23. There's a 4 on the AP test. That's with 23 correct on the multiple choice, which is what you averaged today on those 40 questions. That's with getting a 2, a 2, a 2, a 2, and then bombing the rest of the free response. That's still a 4. It's a hard test. But you can do things. And look at the composite score. The composite score is still under 50%. The composite score is still 49 out of 100. This is a hard damn test. You can do this one. By the way, the correct answer to the Star Wars question is The Empire Strikes Back. So I'm sorry, the rest of you are wrong. Thank you for agreeing with me. Yes, it's the only answer. Anyway, why'd you turn around? Did you argue? All right, whatever. I thought he disagreed with you. Let me see. We're trying to see the answers here. Oh, so you just put like numbers and stuff. Okay, I see. 3. 3? Really? 2, 3? Okay. If any of you put 1, 2, or 3, I'm sorry, we can't be friends. We cannot be friends. I will agree that 7 was better than I remembered it. I just recently rewatched episode 7, The Force Awakens, and it's better than I remembered. Just saying. The Last Jedi was terrible. Just saying. Rise of Skywalker had its moments. Anyway. Sorry. But the answer is Empire Strikes Back. So anyway, back to this. Now, I fear that when I sorted this by accuracy that I discovered that there may end up being a typo in this thing. If you have the, if you have all of the questions lined up, find question number 21. I'm fearing there may be a typo in this one. I'm pretty confident that there is. But I'm just double checking something here. Yeah. You know what they did on this problem? They reduced the fraction. 16 of you chose the non-reduced fraction. Technically, you are supposed to reduce the fraction, but I'm fairly certain that because I didn't write these questions, I just gathered these questions, but I'm fairly certain that it's just like this person being a troll, So consider that one correct. So, maybe you didn't get 23 correct. Maybe you all got like 24 correct. Just saying, It is 20 out of 36 or whatever that decimal is, but the fraction would be 5/9. But yeah, probability of sandals. Let's see this one. Ooh, here we go. And again, whenever I see like a percentage like this, like look at right here, 1 correct, 17 incorrect. Whenever I see something like that, I think to myself, was there a typo? Let's go through the question. This is number 34. This is number 34. USA Today reported that in 1992, 39% of all elementary school students claimed that when they grow up, they want to do something to help other people. However, in a 1995 sample, 128 of a random sample of 317 claim that when they grow up, they want to do something else to help other people. Does this information indicate that there has been an attitude change either way? Which test should be used? Okay. There's no typo. There's no typo. This is a question that if you blink, you'll miss it. If you blink, you'll miss it. Here's what it says, or what it's basically trying to tell you. In 1992, 39% of students said that when they grow up, they want to do something to help other people. And then in 1995, 128 out of 317, whatever that percentage is, said that they said the same thing, basically, that when they grow up, they want to help other people. Does this information indicate that there's been an attitude change? Okay. First of all, it cannot be a t-test. You are dealing with categorical data. You are dealing with categorical data. It is not a t-test. 9 of you chose 2 sample z-test. Tell me, what were the 2 samples? 9 of you chose 2 sample z-test. What were the 2 samples? You might be thinking in your head, well, Mr. Markey, it's the one from 1995 and the one from 1992, right? I'm sorry. Where's the sample information for 1992? How big is the sample size from 1992? They don't tell you that information. And since they don't tell you that information, sorry, you can't just make it up. Can't just pretend that it's there. If this is all the information that they gave you, then this is your claimed null hypothesis, and they're just trying to determine, well, here is the sample proportion. Has it changed from 1992? This is a 1 sample z-test because they only gave you the information on 1 of the samples. If this is all the information that they gave you, then in 1992, you have to assume that that is the claimed number, which it is. They did say children claim that when they grow up. But has it changed? This is a 1 sample z-test. If they did give you a sample from 1992, where if they did give you not just the percentage, but how many participated in that sample, then yes, you would find the difference between those 2 and then test to see if that difference is significant. But this, again, is one of those, dare I say, trolling problems. Because 1992, they're just basically saying, assume that this is true. Assume that 1992 is true. Now here's the sample from 95. Has it changed? That's 1 sample. That's, again, a trolling question. But yeah, definitely not a T. Definitely not a T. A T would be with a quantitative data. This is categorical data. Now, the other thing about this is obviously on the AP test, you won't have 4 options. You'll have 5 options. So obviously keep that in the backs of your mind as well. Here we go. Let's see. Here we go. This is number 15. Number 15. Oh, interesting. Okay, again, like I said, when I see percentages like this, my first thought is maybe there was a typo, but let's read it. A large company wants to conduct a survey to determine the proportion of its male employees who practice yoga on a daily basis. All right. 2 of its regional offices are chosen at random, and all of the male employees at each office are surveyed. Okay. The plan is an example of what type of sampling. I can see why 9 of you chose stratified random. I can see why. Because you said to yourself, well, they only plucked out the males. But in reality, that's the only type of employee that they're interested in. They're only interested in surveying male employees. If you're doing stratified sampling would be splitting people into their strata, the Boston, the cream, the chocolate, and then sampling a little bit from each. But cluster sampling is taking a slice of that pie with the assumption that that slice is representative of the population that you're trying to sample. Now, again, what's the population that they're trying to sample? They're only trying to sample male employees. So if they say, okay, we're going to pick 2 regional offices at random, those are the 2 slices. Those are the 2 slices. And then they survey all of the male employees at those offices. That's what cluster sampling is. It's splitting up the sample into slices, in this case, regional offices. And then, I guess in the case of the pie, taste testing that entire slice. This is definitely cluster sampling. Again, one of those trolling type questions. I like Boston cream donuts. I'm just saying. There's no point to that. I just wanted to point that out there. So, anyone ever have a real Boston cream pie? Like a legit Boston cream pie? Okay, they are delicious. Just saying. Anyway, back to this. Okay, here we go. This is number 33. Number 33. Looks like, oh, wow. Look at the, I don't know if you can see this. This might be a little bit too small for you guys to see. But look at the distribution of people and their choices. 5, 4, 4, and 5. You see something like that. When you see the responses uniformly distributed like that, it kind of implies, perhaps they just guessed. But let's just see what happens. By the way, right off the bat, I haven't even read the question. I have not even read the question. That's wrong. I haven't even read the question, but that one's wrong. And the reason why that answer is wrong, you can't do a t-test for a proportion. T-tests are based on quantitative data. So immediately that one's gone. Let me read the question actually now. A random sample of 49 medical doctors in LA showed that they worked an average of 53.1 hours per week with a standard deviation of 7.2 hours per week. Let me unpack that question for myself. Random sample, 49, large enough, 53.1 hours per week. We're dealing with quantitative data. Quantitative data. So I'm just going to eliminate another choice. I'm dealing with quantitative data. It can't be that one. It's got to be the first 2, or one of the first 2, I should say. Okay. If the California average is 60 hours per week, oh, there's the claim. There's the population parameter claim. That's your mu. That's your assumed mu for this particular problem. Okay. Does this give evidence that the LA doctors work significantly less than the rest of California? What's the one piece of information they didn't give me? There's one piece of information that they did not give me that will then determine what my answer is. They gave me 53.1, which is your X bar. They gave you 7.2, that's not us, which is your sample standard deviation. That's based on the sample of 49 doctors. And they gave you a population mu at 60. They did not give you, which means that we got to use a t-test on that one. Yeah. See, like I said, right? Process of elimination can potentially be helpful, but we got to remember the whole argument for quantitative versus categorical, means versus proportions. With a proportion, with categorical data, if it comes down to Z or T, you got to use Z. But for a T test, for a Z test for quantitative, it comes down to that statement that he just said. Do you have your population standard deviation? That distribution of answers is very interesting. All right. Okay, here we go. What is the probability that a family doesn't have a baby girl until their third child? Okay. Oh, wow. 10 of you chose that second answer there. This is number 24. This is number 24, by the way. Again, like I said, my first thought is perhaps a typo. Well, let's just see what happens. What is the probability that a family does not have a baby girl until their third child? This is clearly probability. They say it right in the problem, but what type of probability? They're trying until they get that first success. This is a geometric problem. This is a geometric probability. You can tell that based on the fact that they want to know the probability to get the baby girl in the third child. That's the first success on the third trial. Oh, doesn't have a baby girl until, okay, interesting. So it seems very logical to just be like 0.5 times 0.5 times 0.5. Does that seem logical? It's like boy, boy, girl. If I multiply those three things together, because again, it would be like you got a boy on the first try, you got a boy on the second try, you got a girl on the third try. If I multiply all three of those together, you get 0.125, which rounds to the first answer. 10 of you chose that second answer. I have my thoughts as to why that would potentially be. I really do want to know why. Like, if 10 of you chose that answer, there must have been a reason for it. Anyone brave enough to share what they calculated or what they were thinking if they chose 0.12 or 0.15? That's literally the first thing that I thought. I didn't want to say it, but that's the first thing that I kind of thought. I'm like, did they do that? Like, oh, I got to get this done. 37 seconds, done. But yeah, this is a geometric problem. You could also do it like this, which is kind of ridiculous. I don't know why people would do it this way. But you could also do geomet PDF 0.5 comma 3, and it spits out the same answer. It spits out the exact same answer. The probability of success, getting the first success on the third trial, on exactly the third trial, which is why it's PDF. It's unfortunate to think this, but again, I just want you to keep this in the back of your mind. You are competing against every other AP student, bless you, against every other AP student that is taking this question or taking this test on that day, on Tuesday. The assumption that you should have is that, well, they're going to get this question right. I got to make sure that I got this question right. With whatever time you have left over after the 40 multiple choice questions, you want to use that extra time just to double check everything. You'd be surprised how many people just kind of like, I don't know. I don't want to say like YOLO the whole thing, because if I say YOLO, then I'm really dating myself to like when you were in elementary school, right? Yeah. Goodness. You know what YOLO means, right? You ought to look out. Yeah. Be careful. You could die. Anyway, back to this. Is the data skewed left, right, or symmetrical? A lot of people pick symmetrical. I guess the argument could be made the argument could be made that it's either skewed right or it's symmetrical. It's not skewed left. And thankfully, none of you chose skewed left. Thank you for that. But I guess, like, I can see why people would think it's symmetrical. But because of that, I'm assuming it's an outlier. I mean, I really don't know if that is an outlier. I'd actually have to do the calculations to determine if it was an outlier, but it appears to be an outlier. But because of that, yeah, it's skewed to the right. That's where the tail is. I know. In fact, if you kind of visualized that curve going over the top of this thing, it's like this. It's like, woo, like that. I mean, yeah, it's right. That looks symmetrical to me. Well, yeah, probably this shouldn't be here. It should just kind of stop right there and stop right there. It's more skewed right than symmetrical. It's a subjective argument, I guess. But because of that outlier, you have to assume what happens when things are skewed to the right. When things are skewed to the right, the average is pulled upward. That outlier is going to cause that average to be pulled upward. That's question number 2. Okay, here we go. What happens to the shape of a sampling distribution as sample means as n increases? Now, hold on. Before I even read the choices, let me just kind of think to myself. That's kind of the definition of central limit theorem. Yeah, that is the definition of central limit theorem. The distribution of sample means as the sample size increases. Now, I know that it becomes more and more normal. So now that I look at the choices, I can see that 2 of the choices do use some verbiage of normal. They do use some verbiage of normal. So it either has to be the second one or the fourth one. And do you know what I'm happy about? Look how many people chose the first and the third one. Yeah, I'm happy about that. Because basically, if you knew nothing else, it would come down to a 50-50 shot. But what ends up happening is, as the sample size increases, the sample mean will get closer to the established claimed mean. For example, if I were to do a sample size of 10 and flip a coin and try to determine how many heads I'm going to get, then I could get, like 6 and then 7 and then maybe I get like a random 8 and then a 4 and then a bunch of 5s in a row. I don't know. And then there's like my sample means, and then I kind of put them and graph them and see what happens. But then if I do a sample size of 100, they're going to be a lot closer to that middle. I might get like a 51 and a 55 and a 48 and a 41 maybe, which is pretty far considering where I'm at, or something along those lines, like a 57 or a 52. But they're going to be more concentrated towards the center, which is why this thing is going to get more narrow. The larger the sample size, the more concentrated your data points will be in the center of that histogram. So it will become more narrow as that peak grows larger. If it's going to become wider, no, it would definitely not become wider. If it becomes wider, it means that the outer limbs are actually growing larger at some point, which is not the case if the sample size increases. There we go. There we go. Good. Let's see here. Okay. Ooh, interesting. Okay. I'm just looking at some of your choices here. Okay. Dannon is supposed to put 29.6 grams of fruit in their fruit-flavored yogurt. To see if enough fruit is being placed in cups of fruit-flavored yogurt, Quality Inspector measures the amount in 27 containers. So it's like a sample size. Don't know if they're randomly selected, but whatever. She found an average of 28.9 grams. Oh, which is less of fruit, standard deviation at 2.8. Does this show that there is probably enough yogurt in the cups? What test should be used? First and foremost, I'm eliminating choice 2. I'm eliminating choice 2 because this is not proportions. Clearly, there's no evidence for matched pairs. You're not doing like a before and after between, two groups that have some kind of connection between them. So it's not a matched pair. Chi-squared. If this were to be a chi-squared, then you would have multiple categories floating around. Multiple categories. Like, free hanging earlobes with a rolling tongue or a non-rolling tongue with attached earlobes. Like those were 4 categories that they could have gone into with counts, with solid counts. But no, these are actually measuring quantitative data right here. It's quantitative data. And they don't give you a population standard deviation, which is why the answer does have to be a one sample t-test of a mean. Know what type of data you have. You got to know what type of data you have. Oh, here we go. I'm going to go to my calculator for this one, actually. This is number 26. Let me erase stuff on my calculator. Let me put some stuff in here, and I'm going to show you what I typed in. Boom. There we go. There's my calculator right there. What is this data anyway? It doesn't even tell you. But they want expected value. If you type that junk in and then do a 1var stat, but keep in mind that you have to do L1, comma, L2, or if you have a fancier calculator, but it wouldn't be this exact interface, but you would still have to put in an L2 for the frequency. It spits out that expected value, that mean at the top, and even an expected standard deviation as well. But that's why that answer is 14. The other way you could do it, actually, yeah, let me do it like this. The other way that you could do it is this. That's the other way that you could do it. Multiply the value of that category times the probability of it happening. Add them all up. 14. Oh, expected value. Oh, here we go. Ooh. Got it. Okay. When I was just pondering, what I was pondering was, what is the difference between the top 2 choices? What is the difference between the top 2 choices? Right there, what I just underlined. PDF is getting the success on exactly that trial. CDF is cumulative, meaning getting the success on that trial or sooner. The probability that Jalen makes a free throw is 75%. What is the probability that he makes his first free throw on his 3rd attempt, on exactly his 3rd attempt, not sooner than his 3rd attempt, which is why PDF is indeed the answer. That is the order that you have to type that stuff in, by the way. For geometric, it has to be the probability of success and then the trial number. If it was a binomial, well, I'll put it right here. If it was a binom, you would have to do the number of trials, probability of success, number of successes, whereas a geomet, it would be probability of success and the trial that you got that success on. Got to be careful with those. Let's see here. Okay. I'll do one more from this because I'm getting out of the red now. I'm getting into the green. Hold on. Let me see which one you guys got correct the most. Hey, look at you guys. You got this one right. Sorry, that's 100% accuracy. I just wanted to look at that. I'm going to have to mark some of these open-endeds wrong, though. How do I do that here? I don't know how. We'll look at it later. Anyway, here. I'll get out of that. I want to try something here. Where is it? With the time that we have, I do want to show you a couple things in terms of multiple choice questions. But the types of multiple choice questions, there we go. The types of multiple choice questions that we have not seen before. Take a look at this sucker right here. Now, I'm not expecting you to choose an answer here, but I want to talk about what this question is about. Look at this thing. Look how terrible it looks. Without even reading the question, if I glance at those choices, the first thing that should pop into my head is chi-squared. That's the first thing that should pop into my head. Just by looking at the choices. Because again, it's like some form of expected minus observed, the whole thing squared over expected, but then they're adding all of them up. This is chi-squared. Let's actually read the question. The table below shows the number of students referred for disciplinary reasons to the principal's office, broken down by the day of the week. A counselor would like to know. Oh, it even says it. Sorry, I didn't even read the question, but it says it right in the problem. A counselor would like to know if such referrals are related to the day of the week. What is the value of chi-squared for the appropriate test? Now, you could do this problem one of two ways. You could attempt to actually perform the chi-squared thing yourself, but what it comes down to is the proper use of that formula. On the formula sheet for the AP test, oh, it moved. For the formula sheet for the AP test, bring this thing up, formula sheet for the AP test. Look at the bottom of page 3. The bottom of page 3, right there on the AP test. They give it to you. Observed minus expected, the whole thing squared over expected. They give it to you. You don't have to memorize that. They give it to you. And because of that, with this particular question, since it is observed minus expected, well, they all, oh, wow, they're all weird like that. Let's go through them one at a time. The 12 is observed. The 12 is observed. So I have to divide by expected. Let me double check that. Boom. I have to divide by expected. Okay. I have to divide by expected, which means it can't be this one and it can't be this one because they're dividing by observed. These are all dividing by 9. These are all dividing by 45. These are all dividing by 5. This is weird. This is so weird. How many students are there? There's like 12 and 5 and 12 and 5 and 9 and 4 and 15. What is that? It's a 10 and then 21 and 25 and 45. There are 45 total students. There are 45 total students. But it's not that one either. Because that's just the total number of students. You're dividing by expected. How many days are there in a week? 5. So if there are 45 students, if it was uniformly distributed, how many would you expect per day? 9. Which is why the answer is indeed B. You can see that right there. You have to divide by expected. That one didn't really actually take much in terms of the calculator, let's say, but it's just more logically using the formula to your advantage. Okay. Like I said, I am going to be sending you that linear regression answers just so you can kind of check it for yourself. I'm not going to be collecting anything for that linear regression thing. As I said, I wasn't going to be collecting anything. You did have a probability minor due for me today. Just putting out that gentle reminder to all y'all. Yeah, so we'll get that thing done. But I am going to be signing off in a few minutes. Monday. Monday is our last opportunity to refresh ourselves on this information. Clearly, I'm not going to be teaching anything new on Monday. I haven't taught anything brand new for a few class periods, and I'm not going to on Monday. We will have some review opportunities. We will have some opportunities for practice. We'll have opportunities for speeches and whatnot and all that wonderful stuff. Just as a heads up on Tuesday, if you haven't already made plans for how you're going to get there, you guys do know what time they expect you to arrive, right? On what, Tuesday? Say again? 11:30. I would highly recommend that you arrive at 11:30. Arrive at 11:30. Because knowing how they want to get the AP test going, if you've been through an AP test, they have to read through all of those directions. And they're going to want to start reading through those directions as quickly as possible so that by noon, you will actually be taking the exam instead of listening to directions. So be there by 11:30. Make sure that you have, and again, you know yourself better than other people, obviously, but I'm just saying, if you need to eat something, make sure you eat something beforehand. Just because you're going to be in there for like 3+ hours. And by the end of it, I don't know, you're going to be mentally drained. On Wednesday of next week, we're going to debrief. It's going to be very low key on Wednesday of next week. You'll see. Wednesday's a half day. I only have you for those 60 minutes, but it's going to be a very low key day. You'll see when we actually meet on Wednesday. But I will also fill you in on what we're going to be doing for the final exam project. But we'll get there when we get there. Fun stuff. Oh, final exam schedule, just so you guys know. It's weird. Yes, technically, I have seniors, so it is going to be like the senior exam type thing. But you'll see. It's a project that I'm going to be working on over several class periods. I'll talk more of those details next week. Anyway, bell's going to ring in about 5 seconds. Yeah. We'll see you then. I unplugged you.
Thank you.
Yeah, if you want to pull that out. If you have not left a comment in the chat, I'll leave it open just for a few extra moments. Thank you, too. See you guys.
Nice tea right there.
You too. See you. Yep, you too. See you. And that stream.